Welcome to Cybercast, decoding today's cyber issues. I'm your host, Kate Macri. Today's episode dives into how federal agencies are working to secure the rollout of 5G infrastructure. Many federal agencies see 5G infrastructure as an IT enabler, something that can help them improve mission delivery. At an FCW virtual event in June, U.S. Customs and Border Protection Executive Director for Enterprise Networks, Christopher Wurst, said he hopes 5G will reduce the load on CBP's network as the agency shifts to edge computing. He also said 5G could boost CBP's network operations, which often languish at the southwest border where connectivity is low. But the Cybersecurity and Infrastructure Security Agency, or CISA, and the National Institute for Standards and Technology, or NIST, worry about cybersecurity concerns inherent to 5G. For example, it will take a long time for 4G infrastructure to be ripped and replaced, which means the initial 5G rollouts will rely on radio access networks, or RAN, via 4G infrastructure. CISA expects malicious actors to target RAN vulnerabilities as telecommunications companies roll out 5G. In an interview with Cybercast, NIST IT specialist Jeff Cichonski explained what NIST is doing to ensure 5G is as safe and secure as possible. Cichonski works on NIST's 5G Cybersecurity Center of Excellence, which collaborates with private industry to develop cybersecurity frameworks and processes for 5G. Cichonski said he's working to ensure that the infrastructure supporting the 5G system is secure for commercial and federal use. Some of the biggest security concerns around 5G right now are interwoven with other concerns, like cloud security. 5G relies on cloud infrastructure, which means cloud security is directly connected to 5G security.
The three biggest security challenges I see facing kind of 5G deployment and technology adoption, I think the first one is really around kind of the configuration, enablement, and deployment of these new security features and new security capabilities throughout the deployment, right? These are very complex systems. Often security threats for mobile networks are taking advantage of misconfigurations or lack of configurations in mobile networks. So I think a big challenge is as we deploy these very, very complex mobile networks, obviously 5G has a lot more capability. They're increasingly complex, focusing on ensuring that the configuration is as expected. There is a security focus during the configuration and kind of deployment planning process to make sure that the networks that are being deployed are enabling and taking advantage of both the security features offered by the 3GPP standards, as well as some of the supporting technologies that are needed to make these systems go. So I think that's one. I think number two kind of ties into that a little bit is ensuring that the infrastructure that is supporting the 5G system, all the cloud computing technologies, all the internet security protocols that are defined by groups like the IETF or Internet Engineering Task Force, making sure that those capabilities and technologies that 5G is being deployed on are operating in a way that's considering security, ensuring we're configuring TLS properly, ensuring we're taking advantage of the capabilities in the underlying cloud infrastructure, things like enabling roots of trust in those chipsets on the servers that are supporting these networks, using the best practice that exists in other cloud application deployments. So as we see 5G take advantage of more cloud native like deployment models, cloud native applications have been around on the internet for a while now. These networks can take advantage of some of those best practices. I think an important part there is making sure as we design these deployments and design the networks, we're isolating as much as possible the critical infrastructure traffic that is supporting kind of that cloud layer of the 5G network. I think that's a good opportunity we didn't have before with some of the legacy networks. We can now kind of split out that infrastructure layer traffic to make it even more resilient. And then I think Lastly, a critical thing for ensuring that the infrastructure that supports the 5G networks is kind of deployed in a secure manner is making sure you're tying that into some type of cybersecurity risk management process, that you're not just ignoring that underlying infrastructure component. And I think like the third biggest security challenge, which to me is the hard one from where I sit and where my expertise is, and I think it's something that's going to shake out as 5G enables more and more use cases and more applications. But it's really going to be managing the cybersecurity risks from the different types of traffic that the network is supporting. So something like an industrial IoT pipeline sensor that's deployed out in the field has a very different security fingerprint and security requirements than something like public safety communications that are riding over that network. So ensuring that the different types of traffic that 5G is slated to support is considered and being secured in the appropriate manner.
Part of the NIST 5G Cybersecurity Center of Excellence mission is to build out a model 5G network to plan for real-world scenarios and security threats.
We are working in a collaborative way with industry to kind of build out a 5G network. And one of the main kind of focus areas of that project is looking at how do we enable the cybersecurity features available in the cloud technology. And one very specific capability we're focused on at that layer is the aspects of kind of hardware roots of trust. So these compute platforms provide a way to kind of measure and attest to the security state or the state of physical servers that are operating these different workloads. So we're looking to actually enable those capabilities at the lowest layer on the chipset, do those measurements so we understand kind of what the state of the system is. We can kind of use those measurements then in a way as we're looking at things like orchestration of network functions. We can take into account, okay, these hardware roots of trust are as expected in my compute cluster. My orchestrator then is able to deploy the network functions in a way that takes that into account. Also, you can take that into account for, say, isolating a security critical network function from a less security critical network function. So we could create a policy based on those trust statuses that says, hey, my AMF for my 5G network, I want to make sure that AMF is only deployed on a compute node that is completely isolated from any user plane function. There's no user plane traffic running through that physical compute node. So taking advantage of some of those lower layer capabilities in the infrastructure and bubbling them up through the orchestration and placement of the actual 5G network or the 5G application that's supporting all of that mobility and connectivity. That's one very specific example. There's other things like how are we configuring things like TLS between the different network functions, make sure we're using the appropriate kind of certificate lifetimes and revocation policies so we know that our network functions are communicating in a secure manner and that our configuration of those protocols takes into account kind of what the best practice is, so that doesn't add to a potential weakness of the network.
Cichonski said NIST wants to streamline and simplify 5G security standards to allow telecommunications companies to deploy as quickly as possible. But it's not that easy.
I think standards are a slow-moving process. They're slow by design, I think. We want to make sure we get these systems specified correctly in a way that works, in a way that is lasting. So as the technology implements those standards, that technology can be deployed for a decent amount of time, and we can leverage that. So something that kind of is attributed to that slowness or the complexity is that 5G is a big complex system with so many different requirements from what types of applications these networks are supposed to support, but also requirements around these networks have to work around the globe. They don't just have to work in the US. They're designed as a global standard. So when I get off a plane in another country, my mobile device, I can turn off airplane mode and it'll work there. So when we get into kind of considering that this is a global standard, there's definitely the fact that different countries have different regulatory regimes that need to be taken into account when we're actually standardizing 5G security, making sure that security features that might be allowed in one country and not allowed in another country are enabled to be configured properly so they work both places, making sure that we're using the correct crypto in certain places, that it's available if one country might have a specific cryptography requirement, that's taken into account. So I definitely think there's some challenges with standardizing 5G security. And I think those are kind of some of the touch points on what is attributed to those challenges.
The recent buzz around zero trust is also relevant to 5G security. Cichonski said zero trust is uniquely suited to protect 5G infrastructure.
Some of these zero trust concepts that are beginning to shake out and that are beginning to be implemented in organizational networks, traditional IT networks, things like ensuring you're isolating traffic, you're using multi-factor authentication. Those concepts are going to be very applicable into kind of the 5G architecture. I don't have a clear line or a clear kind of roadmap into where and when 5G will be able to take those concepts into consideration, and when we're actually going to be able to put a stamp on something and say, hey, this network is kind of zero trust certified or zero trust compliant. I think there are certain concepts and capabilities that the networks are incorporating now that we could equate to zero trust like capabilities and concepts. But I think it's coming. It's definitely something that some of the collaborators we're working with, the network providers and the network vendors, are very, very interested in. There's a lot of kind of technology, software tools out there to kind of enable some of those capabilities. So I know it's of interest to the industry. I'm not sure quite where we are in having those zero trust networks overlap with a full-fledged commercial 5G deployment.
One of the biggest security concerns around 5G, which zero trust could address, is the concept of open radio access networks, or RAN.
This concept of OpenRAN is obviously something of interest to a lot of the technology vendors as well as the operators. So this concept of OpenRAN, that's one very specific group that's working on basically the general principle of desegregating the RAN network, the radio access network. So what they're trying to do is 3GPP define the radio access network. And these different groups are trying to find a way to split out that radio access network even more, to slice it up as much as they can and be able to add additional flexibility and functionality by desegregating that radio access network. So one very specific example is trying to take the actual physical radio, that thing that we see driving down the highway mounted on the cell towers, and kind of take some of the logic that's happening at that radio side, at that antenna that's mounted on the tower, and kind of desegregate it and move some of that logic and run it on similar kind of cloud technologies or cloud capabilities, virtualized somewhere closer to the actual packet core network. So we're kind of splitting out that radio access network and running some of the compute and the logic for the radio on more commodity built hardware that's using similar principles like the core network, where we're actually virtualizing these network functions that are processing the radio. I think there's a lot of opportunity there for kind of innovation. It's less, if we're able to kind of split that out, there's opportunity to kind of innovate around how we're deploying those different pieces of the puzzle. There's definitely some challenges around when you do split that out. There needs to be some well-defined interface, so those splits are still plug and play with different vendors. So you have that flexibility that I think some of these desegregated radio access network initiatives are looking for. From a security perspective, I think it's pretty cool because we can take the kind of the signal processing and the things that are happening more on the purpose-built radio gear now. And if we can move that off and host it on more commodity-built data center servers that have the same security capabilities that we can switch on from a hardware roots of trust perspective, and now that radio, that actual physical layer on the tower, is much less impactful from a security perspective, because that's just a pass through. All the traffic that's traversing that is actually being processed, and the security is terminating on those commodity nodes that are running, whether it's containerized application functions or virtualized application functions. So I think there's a bit of benefit from a security perspective. I know there's a lot of challenges there, because it's still very, very nascent. A lot of folks are trying to kind of do some proof of concepts to get these types of capabilities working. And then again, the challenge around how do we actually standardize around the different interfaces once we do split out the RAN to make sure it still all works together.
While building out a framework for 5G security, NIST also has to balance relationships with manufacturers, service providers, regulatory bodies, and consumers.
It's important to think about 5G from a perspective where 5G technologies definitely have multiple stakeholders. There's consumers of 5G technology, and then there's the service providers who are actually operating the network. So I think as consumers of 5G technology, we definitely see our connectivity to the workplace, to the office, definitely shifting from like fixed line cable at home or cable to the office to being a little bit more dynamic and being able to work remotely. But we're definitely seeing that shift to leveraging these cellular networks to actually for day-to-day business. So as more and more services are running on and accessing organizational systems via these mobile networks like LTE and 5G, I think it's really important for organizations to take these networks into account in their cybersecurity risk management processes, ensuring that the risks are understood, and if need to, they're able to be mitigated with different compensating controls, different types of technologies. Different applications or use cases that leverage 5G are definitely going to have a varying degree of security requirements. So one example that I always think back to is something like ship to shore or last mile connectivity to Navy ships that I know the DoD is interested in as a potential use case for 5G technologies will have a very different cybersecurity risk profile than just an organization using these networks for day-to-day office connectivity and communication. So it's important that as folks build these networks and take into account these 5G networks into their risk management processes, that they're understanding that the different use cases that they're actually leveraging these networks for, and that they might not be one size fits all from a cybersecurity perspective. So from that perspective, there is a lot of best practice out there. It's also something we're working at the NCCOE, at NIST, in this 5G cybersecurity project. The outcome of this effort, we're gonna build a 5G example implementation that really is a holistic approach to 5G cybersecurity. So as I mentioned, focusing both on those standards-defined security features, as well as the cloud technologies that can provide that foundational cybersecurity. So within that is going to come kind of a mapping of the different capabilities that 5G provides that we're demonstrating in this implementation, and kind of mapping those out to different industry security requirements, as well as government security requirements and catalogs of controls, like, for example, NIST 853. So I think that'll be important to understanding how we build those or take into account leveraging 5G technology into our cybersecurity risk processes. I think the second thing is from the operator side. I'm not sure exactly. I'm not an operator. I can't express what the operators would need from a guideline perspective. They are the experts at running these networks. They're hugely complex systems. We're quickly learning as we're in the lab engineering and designing and deploying this 5G system. They're very complex. They provide a lot of different services and capabilities to many different stakeholders. But there are groups like FCC CISRIC. I think CISRIC stands for the Communications Security, Reliability, and Interoperability Council under FCC. They've been focused on mobile network security best practice for years. They have a lot of guidelines out there. There's multiple groups within both ADIS and ETSI working to develop guidance for different portions of kind of from that operator side of these 5G networks. And again, at NIST, I mentioned we're working in collaboration with some of the network operators, specifically T-Mobile and AT&T, And in addition, many of the network technology vendors to kind of build out this reference implementation that enables and demonstrates the security capabilities within 5G networks. So I think that's one thing that we're going to be able to add some value to the community and the ecosystem is by documenting what we do and cataloging those capabilities and how we are able to demonstrate them out using commercial technology.
Cichonski's work on 5G security will have a significant impact on how 5G policy shakes out. Balancing new cybersecurity guidance like Zero Trust with the unique security risks inherent to 5G infrastructure is no easy feat. For more information on how federal agencies hope to deploy and secure 5G, visit our website at governmentciomedia.com. For analysis and insider perspectives on what's trending in federal cybersecurity, subscribe and follow Cybercast. I'm your host, Kate Macri. Thank you for listening.
Cybercast is a production of Government CIO Media and Research. For more podcasts, head to governmentcio.com/podcasts. If you're interested in sponsoring a podcast, contact us at sponsor@governmentcio.com.